Today we're going to talk about recursive formulas. We're going to use this Building with Toothpicks worksheet to help us understand them. The shapes shown below are made with toothpicks. We're going to use these patterns to determine what each perimeter would be for the next shape. So, starting with our perimeter in shape 1, counting up each side, we have 4 total sides, so our perimeter is equal to 4. Moving on to shape 2, counting up just our exterior sides for our perimeter, we are going to have a total perimeter of 8. For shape 3, counting our exterior sides to get our perimeter, we are going to have a perimeter equal to 12. And for shape 4, counting up our exterior sides, we will end up getting our total perimeter equal to 16. Now we want to figure out how we get from one shape to another. So let's create a data table to show us what we have. So if we are comparing our shape to the perimeter, starting with shape 1, our perimeter was equal to 4. Shape 2, our perimeter was equal to 8. Shape 3, perimeter was equal to 12. And shape 4, perimeter was equal to 16. But say we want to figure out what our perimeter would be for shape 5. Instead of drawing out all of the toothpicks, we can figure out what our pattern is. So in order to figure out our pattern, we're going to start with our first term here at 4, and we're going to go to our next term. Our next term is 8. So we're going to figure out if we have a common difference. So in order to find our common difference, we are going to take 8 minus 4. So in that case, we get 4. So to get from 4 to 8, we're adding 4. We can check for each of the next ones as well. So for this one, we can take 12 minus 8, and again, we will get 4. And for the last one, 16 minus 12, we are going to get 4. So this tells us that our common difference is 4. So to summarize what we have found, we can write it out. So for each increase in shape, by 1, the perimeter increases by 4 units. So for shape 5, back to our table, to figure out what we want or what our perimeter would be for shape 5, we're going to take 16 from our previous shape 4 and add 4. So 16 plus 4 will give us our perimeter of shape 5 as 20. So in step 1, it asks us to use the pattern to determine the 5th shape and explain our answer. So in order to get the perimeter for the 5th shape, you add 4 to the previous perimeter. Of 16. So for a recursive formula, when you figure out your pattern by knowing it is an arithmetic pattern, meaning that you're adding or subtracting to get to your next term, from a previous term, this is called a recursive formula. So for part 2, it asks us to write a formula that you could use to find the perimeter of any shape n and explain how we find our formula. So a recursive formula will be written in the form a sub n is equal to a sub 1 plus, in parentheses, n minus 1 times d. So to explain what each of these terms are, n we know is our term number. So for example, if we want to know shape 6, then we would have a sub 6. A sub 1 is our first term, and d is our common difference. So using this, we want to use the information that we found above to fill in our formula. So a sub n is the number that we want to know. It's asking us to find for any shape. Our first term, so our very first shape, is equal to 4. So a sub 1 is equal to 4 plus our n minus 1 multiplied by d. So our common difference we found, we added 4 each time, so it's a positive 4. So at the end, we're going to multiply by 4. So our recursive formula for any shape n is a sub n equals 4 plus n minus 1 times 4. So we can simplify this using the distributive property. So we have a sub n equal to 4 plus, and using our distributive property on this formula, we're going to multiply 4 times n and 4 times negative 1. So we have 4 plus 4n, 4 times n is 4n, 4 times negative 1 will be negative 4. So we can continue to simplify from here. Combining our like terms in this case are 4 and negative 4. So a sub n is equal to 4 minus 4 plus 4n. So our final formula, 4 minus 4 is 0, so we're left with just 4n.